unit equilibrium. So student, today we will see relationship between K. K is the equilibrium constant, you all know. Reaction quotient Q means if you want to calculate constant at any concentration, not at equilibrium, okay, so that is known as the reaction quotient Q. And Gibbs free energy G. Gibbs free energy, students, you know what is the Gibbs free energy. In thermodynamics you already studied about that. Gibbs free energy means the energy which is used for doing useful work, which is used for doing useful work, that is known as the Gibbs free energy. Like students, if any system having total energy is del H, only this one energy it is using in doing works, and the extra energy it will create, it will increase the entropy only, it will create disturbance only. Like students, if we run fan, okay, then we give some electricity, then the amount of electricity is used for running the fan, but whole amount is not used for that. Only small amount of the energy, only small amount of the electricity is used to run the fan, that is known as the Gibbs free energy. But student, that show heating effect also. Heating effect also, if a fan will run for a long time, then it becomes hot because some extra energies are also there, so that create disturbance, means increase the entropy of the system. So Gibbs free energy used for useful works only, already you done. Then students, in Gibbs free energy, thermodynamics, you studied that if change in Gibbs free energy, del G, if it is less than zero means if it is negative, then your system will be spontaneous. Spontaneous. Spontaneous means the reaction take place itself विदाउट एन इनिशिएशन, हमें बाहर से किसी इनिशिएशन की जरूरत नहीं पड़ती रिएक्शन में, हमारी रिएक्शन अपने आप ही सेल्फ होती है. Clear? So that is the spontaneous reaction. The reaction if take place without the help of any initiation, then it is known as the spontaneous. Clear or not? Like student, if you are having some water at the high level, okay, then if you add a pipe on that one, then without any initiation, that water start to flow from high level to the low level, okay. So this one is the spontaneous, this one is the spontaneous. But student, if I want to flow water from low to high, then without any initiation it will not move, okay. By pumping we can do this thing, but without any initiation we cannot do. So that is the spontaneous process. And if we want to move from low to high level, then it will be non-spontaneous. Clear or not? Then if del G equal to 0, if del G equal to 0, then this process will be equilibrium, means at equilibrium. Now you all know very well what is the equilibrium. Equilibrium is that at which state, means concentration of reactant and concentration of product both are the same, okay. There is no change in concentration as the equilibrium. And if students, then greater than 0 means if it is positive, if change in Gibbs free energy is positive, then processing. Then students, here what is the relationship of this Gibbs free energy with equilibrium constant? That also you done. Del G is change in Gibbs free energy of the system at any concentration. Clear or not? At any stage is equal to del G naught. Means it is at equilibrium at standard conditions. Change in Gibbs free energy plus RT ln Q. In thermodynamics, you studied about this reaction also. About this equation also you studied. Clear or not? Then students, from here, if we are talking about equilibrium, if we are talking about equilibrium, then equilibrium students, at equilibrium, what will happen? Here, total concentration of the reactant and product both are the same. Okay, so both side energy change will also be same there. Okay, because both things, reactants and products, we can also consider a heat in reactants and in product also, like that. If our process is endothermic means we are providing heat to the system there, we are providing energy. So here heat energy is working as the reactant. And if any system like exothermic system in which heat is produced, energy is produced, so here heat we will write inside of the product. Okay, so they are also reacting, but in equilibrium state total reactant and product concentration is the equal, it is the same, it is constant. Okay, so that's why students, this Gibbs free energy change will be zero, will be zero at equilibrium. And already I told you del G will be zero at equilibrium. Clear? And at equilibrium students, reaction quotient QC also will be equal to Kc. In previous class we discussed. Yes or not? Reaction quotient will also equal to the Kc. Then put both these value in the equation. If you will put, then del G equal to 0 is equal to del G naught plus RT ln Kc. Yes or not? Then del G is equal to, if you will take RT ln Kc in opposite side, then it sign will be changed. Now it is in plus, then it will be in negative minus sign. RT ln Kc. RT ln Kc. It is clear or not? Yes. Then students, if, because here we want to find relationship between Kc and del G. Okay, then what will be relationship? From here ln Kc, we will take one side is equal to minus del G by RT. Can I write or not? Yes. Clear? Then students, here by solving this we can do exponential both sides, means taking anti-log. This one is logarithm, this is natural log, this is the natural logarithm. Okay, so take anti-log. Anti-log means exponential both sides, e raised to power ln Kc, this is the mathematical term students, will be equal to the e raised to power minus del G by RT. This e exponential, we can say anti-log also. Clear or not? Then students, this term is clear or not? Then this exponential and logarithm cancel each other, they both cancel each other. Then after cancelling, what will happen? Kc is equal to e raised to power minus del G by RT. So this will be the relationship. This will be the relationship between Kc and del G. Okay, if Kc and Qc both are the same thing, but Kc at equilibrium and Qc at any concentration may be. Okay, so in this way we can calculate the, we can find relationship. So from starting, from thermodynamics you know very well this equation, del G is equal to del G naught plus RT ln Q. Okay, here students, at equilibrium change in Gibbs free energy will be zero. At equilibrium change in Gibbs free energy will be zero, so del G will be equal to zero. And at equilibrium QC and KC both are also equal, so put these values. After putting values, then del G equal to 0 is equal to del G naught plus RT ln and Kc. Then del G is equal to minus RT ln Kc. Okay, so from here ln Kc is equal to minus del G by RT. यहाँ तक आई थिंक किसी को प्रॉब्लम नहीं है, बट आफ्टर दैट टेकिंग एंटीलॉग बोथ साइड, antilog both sides, antilog means exponential. Okay, exponential. Then student, e raised to power ln Kc is equal to e minus del G by RT. So from here students, logarithm and exponential both cancel each other, then Kc is equal to e raised to power minus del G by RT. Okay, here ln is logarithm, ln is logarithm. This is the natural log, natural log. And student, we can also convert this one into log base 10. ln is equal to 2.303 log base 10. Log value you can get from log tables. Clear or not? Then students, now we are having this relationship. From this relationship, how can we tell process will be spontaneous, non-spontaneous? Let's see. This one is the relationship. If students, this value of del G, value of del G is negative, negative. क्लियर? आपने केवल पढ़ा था अभी तक कि भी नेगेटिव जब वैल्यू होती है तो प्रोसेस क्या होता है आपका? स्पॉन्टेनियस होता है. प्रोसेस क्या होगा? स्पॉन्टेनियस होगा. सो हाउ कैन यू टेल if this del G is negative, this del G is negative, this one. Here we are having K is equal to E minus del G by RT. If this one value also negative, then negative will be positive. ओके, सो e रेज टू पावर, अगर हमारी इसके पावर अगर हमारी क्या है? पॉजिटिव. ओके, सो दिस वन k overall it will be greater than 1. Overall this value will be greater than 1. Okay, means value of k greater than 1. Value of k will be positive. Value of k will be positive. Okay, and you know very well about direction. When reaction will be forward, reaction will be backward, you know very well. If Kc value greater than 10 raised to power 3, then it will be in forward direction. We already done. So if del G less than 0, if here less than 0 means if del G is negative, so negative value we are having and already negative sign here, so negative and negative positive. Okay, so here students, this one overall value is the positive, and if this already this one positive, so this value, this overall value will be greater than 1. So we can say k also greater than 1 means it is positive. It is positive. And if k is positive means our reaction will be spontaneous. Our reaction will be spontaneous. Okay, so here reaction take place in forward direction, because in initially we have reactants only, and our process is spontaneous, so reactants will start to convert into the products. Okay, then reaction, if reactants convert into the products, then it is forward it is forward, then reaction will be forward, which proceeds in forward direction. Clear or not? Any doubt? If reaction will be in forward direction, then products are present predominantly. Why it is? Because reactants are going to be converted into the products. So according to the time, initially we are having reactants only, but according to the interval of time, reactants are going to convert into the products. So concentration of product is increasing and concentration of reactants is going to the decrease. Clear or not? So here products will be predominantly. This paragraph clear or not? Any doubt? Yes. So just opposite to this one. If del G greater than 0, if del G greater than 0, if it is greater than 0 means it is positive. If it will be positive, then positive and negative, negative. So overall this value minus del G by RT, it will be negative. It will be negative. It will be negative means this value less than 0. This value less than 0. If this value less than 0 means K less than 0. Sorry, not 0, 1. 1 means K less than 1. K less than 1 means it is negative. It is negative. And if it is negative means our reaction will be non-spontaneous. Reaction will be non-spontaneous. Clear? So here that product will be minute because reaction not taking place. Clear or not? It is non-spontaneous process. So without any initiation, reaction is not going on. If it is not going on, reactants are not converting into the products, not converting in products, then concentration of product will be very minor. Okay, so only a very minute quantity of product is formed there. Any doubt in this one? Okay, so students, in this way we can do. You can get numericals also from here. You can see the value of del G note of the phosphorylation of the glucose in glycolysis is 13.8 kilojoule per mole. Find the value of Kc. In this way you can get. Clear? So students, only Kc value is given. Kc value is given here and del G naught value is given here. Sorry, Kc value you will find. Kc value you will find and here value of del G given. So del G naught given, it is equal to, you know very well, minus RT ln Kc. You all know. Okay, and simply you know about Kc also. Kc is equal to e raised to power minus del G naught by RT. This one is the relationship now. So R is not given, R is constant. What type of constant? It is gas constant. It is gas constant. Delta G already given. R is a constant. It is gas constant. Its value will be 8.314 joule per mole per Kelvin. Joule per mole per Kelvin. Temperature only given at 298 Kelvin. And if not given, students, then also you will take 298 because this one is the standard temperature. Already mentioned here. If not mentioned, then you will also take this one value only. Okay. Now you can put values and you can solve. Up to ln Kc you can find. Then Kc, e raised to power this one. So this value you can see from table only, beta. Clear or not? You need log table for this one. This question also same. So you will try to solve this one. Now students, factor affecting equilibrium means what are the factors which are affecting the equilibrium? Students, change in concentration, change in pressure, temperatures, many factors are there which can affect the equilibrium, But students, all these changes take place according to one principle. First of all, we will discuss about that is the Lee Chatterial principle, and student, this one is the important principle. Okay, so tomorrow we will discuss about this one. What is the Lee Chatterial principle and how does the terms concentration, pressure, temperature affect the equilibrium? Clear or not? So, any doubt in this topic? So, thank you. Have a nice day.